Okay, everybody, how are you? Hopefully you're having a great day. It is Friday. Yay, I'm in Seattle, so I thought this would be the best way to teach this stuff. So there's a couple of things I want to teach today. Oh, I don't want this sheet. Hold on. Hold on. Hold on. All right, got it. Got distracted. So here I am, Wednesday night, doing notes, but there's a few interruptions, but it's all good. We can make it. So right off the bat, today's Common Core standard. What we're doing is finding trig inverse operations which we've done before. Okay, we've done sine inverse, we've done cosine inverse, and tangent inverse before. But we're going to use the unit circle to help us out today. Okay, so before I do anything, we have done the inverse symbols. We really have. We have looked at it in a right triangle. We've had an angle, theta. Let's say one side is 5. Let's say the other side is maybe 13. And we've looked at it and said, okay, well, I need to find the angle, opposite hypotenuse. So we've done the sine of the angle is equal to the opposite of hypotenuse. So this is something we've done before. This is old stuff. The main thing I want to talk about is the fact that if you want to find the angle, you have to push the inverse button. So we're going to go, okay, sine inverse of 5/13. You're going to use your calculator using the sine inverse button, right? You're going to go sine inverse 5/13. You need about 22.6. So our angle, theta, is 22.6 degrees. Okay, now we could do the same process on the unit circle. So when we get down to this part here, we're going to actually use the unit circle. Before we do that, let's go back and practice a little bit of unit circle, okay? So let's go back to what we talked about yesterday. So sine. That's sine of an angle, sine of 30. Sine is the y value, right? The y value. I want us to use our unit circle so we get exact answer. I've got 30 degrees in my unit circle. Sine value is the y, which is 1/2. Okay, so the answer is 1/2. Okay, again from the unit circle. Cosine 150. Okay, cosine is the x value. And the x value for 150 degrees, we go to 150 degrees, which is right here. The corresponding x value is the negative square root of 3 over 2. Okay? And again, we did this yesterday. Negative square root of 3 over 2. Now, tangent's a little bit different. What I know about tangent is tangent's the y over the x. So what we want to do is go to 300 degrees, which is here, and take the y over the x. So if I go negative square root of 3 over 2, all over a 1/2, the 2's will cancel, and you're left with just a negative square root of 3. And that's the tangent value, okay? Now, we can do the same thing with radians from the unit circle. Sine, again, is the y value on the unit circle. So go to 7 pi 6. 7 pi 6 is here. We want the sine, so we want the y value. So we want the y value, which is right there. So we get a negative 1/2. Okay, again, all I want to do is just practice a little bit of what we did yesterday. Y value. Cosine is the x value. Okay, so if we want the x value, we can go to pi, negative pi thirds. So negative pi thirds is, let's see, if pi thirds is a rotation forward to here to 6 degrees, the negative pi thirds has to be a rotation down here to 300. So we're going to rotate this way. So we're right here at 300 degrees for a negative pi thirds. We want the x value, which is 1/2. Okay, scoot up. X value, which is 1. Here's 300. X value of 1/2. Now tangent of 3 pi fourths. Tangent of 3 pi fourths. Okay, 3 pi fourths. Tangent is the y over the x. Okay, but I have my tangent values on the outside, right? So this is what we did yesterday. We put our tangent values on the outside, so we don't have to do y over x. But that would just simply be a negative 1. Okay, so far, so good. Now, let's do the opposite. So, if we're going to use the trig inverse, whether it's trig inverse, we're going to be finding an angle, okay? It says 2 answers, and you're going to see why there's 2 answers. So, what I want to do is this. To do this answer, I'm going to find an angle. I'm going to find an angle. Let's find it in terms of radians. I like radians better. Radians. Okay? Let's find the answer in terms of radians because radians are better. So 1/2, let's see. I'm looking for a y value. A y value of 1/2. That's what I want to do. Okay, I'm looking for a y value of 1/2. So I'm going to look at my unit circle. Okay, y value 1/2. Here's one right here. Okay, but it says 2. There's technically 2 answers. There's one at 30 degrees and one at 150. They're both correct. Okay, or better yet, in radians, there's one in pi 6 and the other is at 5 pi 6. So we've got 2 answers. We've got theta equals 30 degrees, but I don't want that. That's stinking radians. I want radians, it's stinking degrees, so I want pi 6. That's one answer. And then the other answer, okay, I'm looking for 1/2. Again, 1/2 for y value. Here it is, and there it is. Okay, see 1/2 for y value? So I'm looking for 150 degrees. So theta equals 150 degrees, but I really don't want degrees. I want radians, which is 5 pi 6. Okay, those are both the correct answer, but really we only want one answer. So which one's closest to 0? Well, if I start at 0, pi 6 is. 5 pi 6 is a rotation all the way around here. So we just take the one closest. So we don't really take the 5 pi 6 unless we're asked for 2 answers. Okay, so pi 6 is the closest answer. So sine inverse of 1/2 gives me an angle of pi 6. Okay, let's go on to the next one. Cosine. So we're looking for an x value of negative square root of 3 over 2. So let's see what we've got. Negative square root of 3 over 2. Negative square root of 3 over 2. X value. Negative square root of 3 over 2. Right here. All the way over there. And there's a second one. The second one you got to keep going. Okay, so this is 150 degrees. Here's one, and then if I keep going to the other one, oh yeah, all the way over to here is the second one. Okay, I don't want the second one because that's 210 degrees. I want the closest one, which is 150. So really, we're going to say, okay, theta is equal to 150 degrees, right? Okay, it's the closest one, 150 degrees, but let's use the radian instead. 5 pi 6. That's the answer I want, okay? Now, tangent, square root of 3. Okay, let's take a look at our unit circles. Tangent, square root of 3. Tangent, square root of 3. So tangents are on the outside. Here's one at 60 degrees, and then there's another one that goes all the way around to here. Okay, well obviously this one here is closer. Okay, this one here is far away. Let's take this one at 60. So theta is 60 degrees. That's my tangent value, but we want the one that's closest. That's the 60, but let's do it in terms of radians. Theta is equal to pi thirds. Let's use radians. Okay. Now, sine inverse of 2. There's a problem with this one. This one will not work. You see, sine is the y value, and the highest y value you can get to is 1. You'd have to be off the unit circle. So this will give you an error. In fact, the calculator will give you an error also. So it's a domain error. So we're just going to put does not exist. Does not exist. In fact, if you tried it on your calculator, check it out. It won't work. And this is why. Sine inverse of 2 won't work. Domain error. Because the y value on the unit circle can only go up to 1. It's off the unit circle, so it will not work. Okay? All right, let's practice a couple more. Okay, example 11. Tangent inverse of negative 1. Okay, so let's find tan of 1. Tan of 1 for tan value. So my tangent values, here's 1, and here's the other. Okay, so one answer is at 45 degrees, the other's at 225. Which one's closer? One's closer is at 45 degrees. So theta is equal to 45, but we don't want degrees. We don't want degrees, we want radians. 45 degrees is the same thing as pi force in terms of radians, so we want pi force. That's the angle we want in terms of radians. Okay, how am I doing? Hopefully not too fast. Let's look at example 12. So example 12, let's put question mark because it's a trick. There's a trick to it, okay? And I'm going to show you the trick. Okay, we're looking for a y value of negative 1/2. Turns out there's one here, and there's one here. Okay? Now the question is, which one's closer? Well, technically this one's closer to 0, right? This one here is closer, okay? But to go to 330 degrees you can't, because if you really did want to go closer, 330 degrees, now watch. It looks closer, doesn't it? Negative 1/2, it does look closer. But to get to it, you have to go all the way around to 330. That's not closest to 0. 330 degrees is not all the way around. It's not closer. However, if we can go backwards to it, it would be shorter. So if I went backwards, I would go back negative 30 degrees. Does that make sense? This would be a negative 30 degrees. So if I go backwards negative 30 degrees, that's the same as a negative 30 degrees, then I would have theta equals a negative 30 degrees. Okay, now that is correct. However, in radians, that would be the same thing as a negative pi over 6. Okay, 30 degrees is pi over 6, but negative 30 degrees is a negative pi over 6. So that's a little bit tricky. All right, give us a second to think about that. Okay, example 13. Let's check it out. Okay, example 13 is cosine. Cosine's an x value. We need x value of 1/2. It's right there. And there's another one here. Okay, which one's closer? Well, hopefully 60 degrees seems closer to you than going all the way around 300. So I would go for the 60 degrees. 1/2 y value, straight to the 60 degrees. So I'm going to say, all right, theta is equal to 60 degrees, but we don't want degrees. 6 degrees, we want the radians. We really want pi thirds. So let's go pi thirds for the answer. Okay, how am I doing? Hopefully not too fast. Remember, you can always pause the video. Okay, let's turn the page. Okay, now cosine theta equals 0.6. So we're going to use the calculator. We really are. And we want it in terms of degrees, right? So now I want to make sure, first of all, I know it's good degrees because I see the degrees. So make sure I'm degree mode. And we will do radian mode, but not today. Okay? So I go to my mode button. I'm going to make sure I'm in degree mode, not radians. Okay? So I'm in degree. Okay, good enough. So if I want the angle on this one, if I go cosine inverse of 0.6, I'll get theta, right? So let's do that, okay? All right. So if I go cosine inverse of 0.6, and I get an answer of about 53 degrees. Let's say we'll round it to 53 degrees for right now, okay? Now the problem is that angle is not between 0 and 180, right? So let's just try and take a look at a picture. Okay, let's draw a picture. Okay. All right. So if I've got 53 degrees here for theta, we are looking at its reference angle. Well, it could have another reference angle here between 0 and 180, but that would work. 53 degrees will work. Okay? Okay, does that make sense? Now example 12 is going to be different. Okay, let's take a look at sine inverse of 0.8. Now let's use our calculator. Go sine inverse 0.8, and we get an answer of about 53 degrees again. That's weird. So then theta, in this case, is also 53 degrees. Okay, so let's look at our picture. I did this on purpose, didn't I? So here's 53 degrees, but the only problem is I want an angle between 270 and 90. Okay, so let's see, 90 and 270. That's over here, isn't it? Okay. Okay, that's over here. So since y is the y value, I'm going to take and I'm going to reflect this line over. Let me find a good pen here. I'm going to rotate this over the y-axis, okay? Okay, so this 53 degrees is here. So the angle I want has to be between 90 and 270, okay? So that would have to be, ready? That would have to be this full angle here. Okay, let's measure that. Well, I know if that's 53, right? I'll go 90 minus 53, but better yet, if I go 180, so if I take 180 minus 53, I'll explain this better when I get back. It's a little hard. I get 127. So the angle I'm looking for is 127 degrees, okay? Okay, last but not least, tangent. We want it between 0 and 180. Well, that's not too bad, except for it's a negative, but I think we can figure this out, okay? So again, if it's tangent inverse of a negative 1.3. Use my calculator. I'm going to go tan inverse of negative 1.3, and I get an answer of about negative 52 degrees. What? Theta is negative 52.4. Well, how does that work? Well, let's check it out. Let's draw a picture. Okay? Let's draw a picture. Okay? All right? So, negative 52 degrees is about here. It's that angle right there, okay? So, this is about a negative 52.4, but I want an angle between 0 and 180, so I want an angle up here. Well, it turns out that if I take 180 and add that to that negative 52.4, you get its reference angle on the other side. So the other side is right up here. So if I take my 180 and add that negative 52.3, I get an answer of about 127.5. Let's round it to 6. 127.6. So this angle that we want right here is between 0 and 180. And that's the one I want. So that's going to be, my angle is 127.6 degrees. Okay? So it's a little bit harder. This is the reference angles, and I'll talk about this some more when I get back on Monday. But for today, I want you to try page 953, 2 to 24 even. Please try. Please do the work. Give it your best shot. All right?